This is Concept A classes, and today we'll deal with part 2 of chapter 2 in class 9 science. Is matter around us pure? So in part 1 we saw what is a mixture, the different types of mixtures, homogeneous mixtures and heterogeneous mixtures. Then we studied about solution, colloidal solution, suspension, Tyndall effect and all. In this part we'll deal with how we separate the components of a mixture, the physical and the chemical changes, and then what are the types of pure substances. So let's begin the chapter. So first let's see how we separate the components of a mixture. So in the last part we saw that most of the natural substances are not chemically pure. Now what was the term pure? A pure substance consists of a single type of particle or a single form of matter, whereas most of the natural substances, say for example seawater, soil or minerals, they all contain more than one type of particle or one type of pure substances. So to get the individual components from such mixtures, different methods of separation are used. In the case of heterogeneous mixtures, what was heterogeneous mixtures? Those are the mixtures which contain physically distinct parts and which are non-uniform in nature. So for example, salt and sulfur, that is a heterogeneous mixture. Oil and water, that is also a heterogeneous mixture. We have already explained it in part 1. So such mixtures can be separated by simple physical methods like hand picking, sieving, filtration, etc. If you want to know more about such simple physical methods, message me in the comment section. I'll give you a separate video on this. Now the separation helps us to understand more about this individual components and how we could use that components as well. Now the separation of components of a mixture depends on the type of mixture as well. So let's understand more about the different methods of separation of the components of a mixture. So the different methods are separation by evaporation, centrifugation, separation of immiscible liquids by separating funnel, sublimation, chromatography, fractional distillation, separation of components of air using this fractional distillation, and crystallization. So let's understand each of these topics briefly. So first let's see the separation by evaporation. Now what is evaporation? Evaporation is the process by which a substance undergoes transition from its liquid state to its gaseous state below the temperature at which it boils. Or in simple words, it's the process by which the liquid water enters the atmosphere as a water vapor. So we have already explained about this evaporation in chapter 1 of class 9 science. If you have any doubt, please refer the slides of that chapter. Okay, so first let's understand the separation by evaporation through a simple activity. Here we have to obtain a colored component dye from a blue-black ink. So ink is actually a mixture of dye with water. Okay, for example, if it is a black ink, it is a mixture of a black dye with water. If it is a blue ink, it is a mixture of a blue dye with water. So we have to obtain this dye from this blue-black ink through the process of evaporation. So first let's take half a beaker with water, put a watch glass on the mouth of the beaker, put a few drops of ink on this watch glass. Now start heating the beaker. Actually we do not want to heat the ink directly, so that's why we are heating the beaker. Now we can see that the evaporation is taking place from this watch glass. Now continue heating as the evaporation goes on and stop heating when you do not see any further changes on this watch glass. Now observe carefully. What can we see? We can see that the water in the ink gets evaporated, whereas the dye remains as a residue on the watch glass. We already know that the ink is a mixture of dye and water. So what happened here? All the water inside this ink got evaporated, whereas the dye remained inside this watch glass. Hence we are able to separate the volatile component. What do you mean by volatile? It means a substance that undergoes evaporation. So which component actually undergoes evaporation here? Water. So we can separate water from its non-volatile solute. Which was the non-volatile solute? Dye, by the method of evaporation. Now what are the applications of evaporation? drying clothes under the sun, ironing of clothes, cooling down of hot tea and other hot liquids, extraction of salt from seawater, melting of ice cubes, preparation of common salt, evaporation of acetone, drying of water. So these all are the applications of evaporation. Now let's see what is centrifugation. Centrifugation is actually a technique which is used for the separation of particles from a solution according to their size, shape, density, viscosity of the medium and rotor speed. So here actually the mixture is placed inside a centrifuge tube and then it is placed inside this centrifuging machine. Then this mixture is rotated, causing the denser particles to move down and the lighter particles to move up. So it is actually a process of separating particles using a centrifugal force. We'll understand more about this centrifugation and centrifugal force all in your higher classes. Just now we have to understand that centrifugation is a process of separating particles from a solution using centrifugal force. So let us understand this through a simple activity. So here we'll see how we can separate cream from milk through centrifugation. Now take some full cream or milk in a test tube and centrifuge it using a centrifuging machine for 2 minutes. And or if you do not have a centrifuging machine, we can do it manually using a milk churner. So what can we see? We can see that milk being denser, it settles down at the bottom. Cream being lighter, it floats on the top. So hence we are able to separate cream from milk through this process of centrifugation. So sometimes the solid particles in liquids are very small and it is not able to pass through a filter paper. So in these cases the filtration technique cannot be used for separation. So for such mixtures only centrifugation can be used. So the principle is that the denser particles are forced to move at the bottom and the lighter particles stay at the top when they are rotated rapidly. Now the applications of centrifugation are used in diagnostic laboratories for blood and urine test. They are used in dairies and home to separate butter from cream. They are also used in washing machine to squeeze out the water from wet clothes. Now let's see how we can separate two immiscible liquids. So before that, what are immiscible liquids? Immiscible liquids are those which won't mix to give a single phase, or in simple words we can say that immiscible liquids are those liquids which do not mix with each other. Say for example oil and water, do they mix with each other? No. We can see that the oil floats on the top of other. So such liquids that do not mix with each other are termed as immiscible liquids. So let's see how we can separate two immiscible liquids, that is by using a separating funnel. So here we are trying to separate kerosene oil from water. So for that we first pour the mixture of kerosene oil and water in a separating funnel and we let it stand undisturbed for some time. So what are we able to see when we let it undisturbed? We can see that the water, it moves down whereas the kerosene oil moves up. So we can see separate layers of oil and water. And if we open the stopcock here of the separating funnel, we could separate the water into another beaker. Okay, and when this water is completely removed, we could stop the stopcock, okay, or close the stopcock. Then what happens? You could see that the kerosene oil is left behind in this separating funnel. Hence we are able to separate two immiscible liquids using a separating funnel. So the principle is that the immiscible liquids separate out in layers depending on the densities. So why did this water move down and the kerosene oil moved up? That is because the water is denser than oil. So that is why separate layers of oil and water were formed. And because of the separation, we were able to identify the two immiscible liquids. Okay, so the same technique is used in many other applications in order to separate mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave this molten iron at the bottom of the furnace. So this application is used in many other cases as well. Now let's understand how we can separate the components of a mixture through the process of sublimation. Now what is sublimation? Sublimation is the transition of a substance directly from solid to gaseous state without passing through the liquid state. We have explained Sublimation 2 in your first chapter. If you have doubts, please refer the corresponding slides. So let's understand more about this through a simple activity where we separate a mixture of salt and camphor. So for this, we have to take camphor and salt and crush it and put it in a china dish. Now put an inverted funnel over the china dish and put a cotton plug on the stem of the funnel. Now heat slowly and observe. What can we see? We can see that on heating, the camphor gets evaporated, thereby undergoing sublimation. So this component can be called as a sublime component. Whereas the salt, it remains on the china dish. Okay, so to separate such mixtures that contain a sublimable volatile component, now which was the sublimable volatile component here? Camphor, from a non-sublimable impurity which is salt, the sublimation process is used. Now some examples of solids which are sublime or which undergo sublimation are ammonium chloride, naphthalene and anthracene. So in all these solids, they directly undergo transition to gaseous state without undergoing a liquid state. Okay. So the applications of sublimation are: sublimation and erosion cause ablation, a process that wears down the glaciers. Sublimation of iodine may be used to reveal the latent fingerprints of the paper, and sublimation is used to purify compounds. Now let's see what is chromatography. So chromatography is actually a laboratory technique which is used to separate the components of a mixture. So it is actually used to separate those solutes or different solutes which dissolve in the same solvent. So in order to understand how this technique can be used, let's perform a simple activity. Here we are using a dye and we are checking if the dye in a black ink is a single color or not. So for that, first we take a thin strip of filter paper. We draw a line on it using a pencil which is approximately 3 cm above the lower edge. Now put a small drop of black ink at the center of the line. Now let it dry. Now lower the filter paper into a jar or a glass containing water so that the drop of the ink on the paper is just above the water level. Now leave it undisturbed and watch carefully as the water rises up on the filter paper. So we could see the filter paper would change like this. So we know that the ink that we use has water and dye in it. So water here acts as a solvent and the dye, which is a solute, is soluble in it. Okay, so as the water rises on the filter paper, what does it do? It takes along with it the dye particles. That is, when the water passes through this black ink, it takes all the pigments along with it. Okay, so when this water reaches here, it takes the pigment all like this. So we know that dye is a mixture of 2 or more colors. So the colored component that is more soluble in water rises faster, and in this way the colors get separated. So this process of separation of components of a mixture is known as chromatography. The term chroma is actually a Greek word which means color. This technique was actually used first for the separation of colors, so this name was given. So chromatography is a technique used for the separation of different solutes that dissolve in the same solvent. Now the application of chromatography are: it is mainly used to separate the colors in a dye, the pigments from natural colors, and the drugs from blood. Now let's see how we are able to separate the components of a mixture through fractional distillation. Now before entering into fractional distillation, let's first understand what distillation is. Now distillation is the process of separating the components from a liquid mixture by using selective boiling and condensation, or by using heating and cooling. Okay, so let's understand how we are able to separate a mixture of 2 miscible liquids through distillation. So here the 2 miscible liquids that we are using are acetone and water. So what do you mean by miscible liquids? It means that those 2 liquids mix with each other. Okay, so if we took this mixture in a distillation flask and we fit a thermometer in this flask, we arrange the apparatus as shown in the figure, and we heat the mixture slowly, keeping a close watch at the thermometer. Now we can see that when the acetone reaches its boiling point. So the boiling point of acetone is actually 56 degrees Celsius and the water has a boiling point of 100 degrees Celsius. So when acetone reaches its boiling point, it starts to vaporize. Okay, and all these vapors, they flow into this condenser where it gets cooled and it converts into liquid again. So here the liquid acetone is collected in one beaker and the water remains inside the flask itself. Hence we are able to separate this mixture. So this method is called as distillation. So distillation is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have a sufficient difference in the boiling point. Here water had a boiling point of 100 degrees Celsius and acetone had a boiling point of 56 degrees Celsius. So the difference is about 44 K. And so they had a sufficient difference. But if the difference was less than 25 K, we couldn't use this distillation. So if the boiling point, the difference in the boiling point is less than 25 K, we use fractional distillation. So fractional distillation is the separation of a mixture into fractions differing in the boiling point by means of distillation, typically using a fractionating column. Or in simple words, fractional distillation is used to separate two miscible liquids having closer boiling point. So as we said, to separate a mixture of two or more miscible liquids, they should have a difference in the boiling point which is less than 25 K. Only then fractional distillation could be used. So this fractional distillation is used for the separation of different gases from air, for different fractions from petroleum products, etc. So this apparatus is similar to that of distillation, except that a fractionating column is fitted in between the distillation flask and the condenser. These two figures are the same, just quite colorful, that's it. Okay, so this fractionating column is actually a tube which is packed with glass beads, and these beads actually provide surface for the vapors to cool and condense them repeatedly as shown in the figure. So let's understand this through the activity. Okay, here first the mixture is heated and the component of the mixture having the less boiling point, it vaporizes after reaching its boiling point. So the vapor, it is actually cooled when it reaches the condenser and it is collected in another flask in its pure form. Now the second component, it also starts to evaporate, but it is condensed by the fractionating column, and hence what happens, this vapor, it trickles down back into this flask. But as soon as the first component is completely collected, the temperature would start rising. So at this stage the receiver is changed and the second liquid is collected. Hence the two liquids can be separated using a fractional distillation. Separation of components of air. So let's see how we can obtain the different gases from air. We know that air is a mixture of gases. It consists of argon, nitrogen, oxygen, carbon dioxide, etc. So we can separate the components of air by fractional distillation. So this flow diagram, it actually shows the steps of the process. First, the air, it is compressed and cooled by increasing the pressure and decreasing the temperature. So because of this, liquid carbon dioxide is formed, okay, and it flows out as dry ice. Then the rest of the air or the liquid air, it is allowed to warm up slowly in the fractional distillation column. Then the gases get separated at different heights due to the different boiling points. So this is the boiling point of oxygen, argon and nitrogen. So if we want to get oxygen from air, we have to separate all other gases. So just as we said, first the air, it is compressed by increasing the pressure, and then we decrease the temperature. Okay, then liquid air is formed, the liquid carbon dioxide, it flows out as dry ice. Okay, and then the rest of the remaining liquid is warmed up in the fractional distillation column. Then the gases, it starts getting separated at different heights due to the difference in the boiling point, and then we separate oxygen from this. So we are able to separate the components of air through fractional distillation. So let's see what is crystallization. A crystallization is a process by which a solid forms. That is where the atoms or the molecules here, they are highly organized to form a structure known as crystal. So here we are using this process of crystallization to separate a pure solid in the form of its crystals from a solution. So let's understand this through an activity where we obtain a pure copper sulfate from an impure sample. Here we take about 5 grams of impure sample of copper sulfate in a china dish. We dissolve it in minimum amount of water. Then we filter the impurities out. Okay, then we evaporate the water from this copper sulfate solution as to get a saturated solution. Now we cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. So after a day we are able to obtain the crystals of copper sulfate in a china dish. So this process is actually called as crystallization. Okay, so the crystallization method is used to purify solids. Let's take another example. The salt we get from seawater, it has many impurities in this. So to remove these impurities, we can use the process of crystallization. So crystallization is a process that separates a pure solid in the form of its crystals from a solution. Now, crystallization technique is better than the simple evaporation technique. Why is that? It is because during evaporation, some solids may decompose, or some solids like sugar, they may get charred on heating to dryness. But in the case of crystallization, no problem happens like this. Okay. Another issue is that during evaporation, some impurities may dissolve in the solution even after filtration. So this contaminates the solid. So because of this, we can say that crystallization technique is better than evaporation technique. Now let's see the applications of crystallization for the purification of salt that we get from seawater, or separating the crystals of aluminum from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we are able to get a pure substance. And with the advancement in technology, many more methods of separation techniques have been devised. So let's take a real-time example of how we separate the components of a mixture so as to get a pure substance. Let's take the case of drinking water. In cities, the drinking water is supplied from waterworks. So a flow diagram of a typical waterwork is shown in the figure. So let's see. Here we have a reservoir. The water is there. This water contains many impurities. It consists of many large contaminants like sticks or stones, or many chemicals or inorganic materials and all. So first, this water, it flows through the sedimentation tank. Here all these large particles like debris or stones or sticks, they get sedimented in this tank. Okay, it settles down at the bottom. Then the water inside the sedimentation tank, it flows through this loading tank. Okay, so here we separate the small particles that are suspended in this water, and it is allowed to sediment the suspended impurities. So all these impurities are settled down in this loading tank. Then this treated water is again allowed to pass through a filtration tank. So this tank, it consists of fine sand, it consists of water, gravel, coarse gravel and all. Okay, so when this water is passing through this filtration tank, all the small solid impurities, they stay in between the sand. If there is any dirt, they gets mixed up with this gravel. And what happens, the water gets treated here. Okay, then this treated water, it gets ready for disinfection. So how do we disinfect? We use chlorination, or many other disinfectant techniques are there. Here we are using chlorination. So all the harmful microbes or the bacteria or viruses, they're all killed by adding disinfectant like chlorine tablets through the process of chlorination, and we kill the bacteria, and finally we get water through a tap in our home. So this is how we get a pure form of water from this mixture. So if you want a detailed lecture of how this works, message me in the comment section. Now let's see what are physical and chemical changes. So first let's understand what are physical properties. The properties that can be observed and specified, like color, hardness, rigidity, length, fluidity, density, melting point, boiling point, etc. are called as physical properties. Now, what do you mean by a physical change? Say, for example, the interconversion of states. It is a physical change because here changes occur without a change in the composition and no change in the chemical nature of the substance. So, physical change is a change where there is no change in the composition and no change in the chemical nature of the substance. Here, although ice, water, water vapor, they all look different and they all display different physical properties, they are chemically the same. Ice have two atoms of H and one atom of oxygen. Water also has H2O, right? So all the chemical composition all are the same, even though they look different and they display different physical properties. So here no new substance is formed. So this change is called as a physical change, and these changes are reversible as well. But if we take the case of water and the cooking oil, they both are liquid, but the chemical characteristics are different. They differ in smell, inflammability. We know that oil, it burns in air, whereas water, it extinguishes fire. So it is that chemical property of oil that makes it different from case of water. Okay, so that is the meaning of chemical properties. Now, what is a chemical change? Say, for example, burning. It is a chemical change. During this process, one substance, it reacts with another to undergo a change in the chemical composition. So here wood, when it burns, okay, what happens? It is undergoing a change in the chemical composition, right? The wood, it is completely burned and we get a new substance. What all other substances we get? We get ash, we get gases like carbon dioxide and smoke, and a lot of heat energy is also released. Okay, so a chemical change, it brings a change in the chemical properties of matter and we get a new substance. So these all are the chemical properties. So chemical changes are the changes in which a new substance is formed, and a chemical change is also called as a chemical reaction. Let's take another example. During a burning of a candle, here both physical and chemical properties takes place. Why do we say that? When a candle is burned, what happens? The wax, it melts from solid to liquid, okay, and here no new substance is formed, and hence it is a physical change. Okay, and we can reverse it back, right? From this liquid we could change it back to solid as well. So this is a physical change. Now we say that the burning of a candle, chemical change also takes place. Now how is that? That is when the wax near the flame, it burns, the oxygen in the air, it reacts to form carbon dioxide. Now this carbon dioxide, it cannot be converted back to wax and a new substance is formed, carbon dioxide is formed here. So chemical change also took place here. Now let's see what are the types of pure substances. So we already studied what is a pure substance. Now let's see what are the types of pure substance. On the basis of the chemical composition, substances can be classified either as elements or compounds. So let's understand more about elements and compounds. So first let's see about elements. Now Robert Boyle was the first scientist to use the term element in 1661. Later Antoine Laurent Lavoisier, he was a French chemist. He was the first to establish a useful definition of an element. So he defined an element. So according to him, an element is a basic form of matter that cannot be broken down into simpler substances by chemical reaction. So an element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Or we can also say that element is a substance made up of only one type of atoms. We'll study more about atoms in the next chapter. Say for example carbon. Here the carbon is fully made up of carbon, C atoms. See? Now elements can be normally divided into metals, non-metals and metalloids. So let's see each of these briefly. The first one is metals. So metals are those substances that have the following properties. They have a luster, that is a shiny appearance. They are silvery grey or golden yellow in color. They are good conductors of electricity and heat. They are ductile, that is they can be drawn into thin wires. They are malleable, that is they can be hammered into thin sheets. They are sonorous, they can make a ringing sound when hit. Some of the examples of metals are gold, silver, copper, iron, sodium, potassium, lead, etc. And mercury is the only metal that is liquid at the room temperature. We have already studied about metals in class 8. I'll add the video in the end of the session. If you have any doubts, please refer that chapter. Okay? Now let's see about nonmetals. The nonmetals are those substances that do not show any of the properties of metals. They are not lustrous, they are not sonorous, they are not malleable, not ductile, but they show some or all of the following properties. They display in a variety of colors. They are poor conductors of heat and electricity. As we said, they are not lustrous, they are not sonorous or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Now let's see about metalloids. So some elements, they have intermediate properties between those of metals and non-metals. That is, they show both the properties of metals and non-metals. Such elements are called as metalloids. Say for example, boron, silicon, germanium, antimony, etc. So these all are the examples of metalloids. So this is the periodic table. It displays all the chemical elements. There are about 118 elements. Out of this, 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature and 2 elements are liquid at room temperature. One is mercury, as we said, and the other is bromine. So let's see what are compounds. Now a compound is a substance composed of 2 or more elements chemically combined with one another in a fixed proportion. And the compounds are made up of more than one type of atom. Say for example, water. This water is a compound as it's composed of 2 elements, 2 atoms of hydrogen and 2 atoms of oxygen, which are chemically combined with one another in a fixed proportion, 2:1 ratio, right? So a compound is a substance which is composed of 2 or more elements chemically combined with one another in a fixed proportion. So what do we get when 2 or more elements are combined? In order to understand that, let's take an activity. Let's consider 2 groups. Give 5 grams of iron fillings and 3 grams of sulfur powder in a china dish to both the groups. For group 1, mix and crush this iron fillings and sulfur powder. For group 2, mix and crush this iron fillings and sulfur powder. Heat this mixture strongly till it's red hot. Remove from the flame and let the mixture cool. Now in the case of group 1 and group 2, check for magnetism in the material obtained. When we bring magnet to the first group, is it attracted towards the magnet? We can see that the iron fillings inside this mixture gets attracted to this bar magnet. Okay. Now in the second case, where we heated this iron fillings and sulfur, it is not attracted. Okay. Now compare the texture and color of the material obtained by the groups. Now when we add carbon disulfide to one of the material obtained, we stir well and filter. Okay, so we added this carbon sulfide and here we got a yellow solution and we obtain a gas which is hydrogen, okay, which is colorless and it was odorless. But when we added hydrogen sulfide to group 2, what happened? We got a colorless gas with the smell of rotten eggs. So the products obtained by both the groups showed different properties, though the starting materials were the same. The group 1, they have carried an activity involving a physical change, whereas in the case of group 2, a chemical change, right? A chemical reaction took place when we heated both the iron fillings and sulfur. Okay, so the material obtained by group 1 is actually a mixture of 2 substances. The substances were iron and sulfur, and when they were mixed together, we saw that when we brought a magnet close to it, all the iron fillings got attracted to it. right? So the properties of the mixture are same as that of its constituents. So the mixture had the same properties of iron as well. Okay, so we can say that the first material obtained by the group 1 is a mixture, and this was actually a physical change. No new product was formed. Now the material obtained by group 2 is actually a compound. Why do we say it as a compound? Because on heating these two elements, we got a compound which was totally different, and it had different properties compared to the combining elements. The composition of the compound is same throughout, and the texture and color of the compound are same throughout as well. So here a chemical change took place because a new substance, a compound, was formed. Now let's see the difference between mixtures and compounds. Now elements or compounds just mix together to form a mixture and no new compound is formed. That is, mixtures are formed by mixing two or more elements or compounds, whereas compounds, they are formed by the reaction between two or more elements. A mixture has a variable composition. Say for example, salt and water, it is a mixture. Salt and water, they do not have any particular ratio. Okay, they ratio of two or more substance may not be the same, whereas in the case of compounds, the composition of each substance is always fixed. Say for example H2O or carbon dioxide, that composition, that is one atom of carbon and two atoms of oxygen, so that ratio is always fixed. In the case of mixtures, it shows the properties of the constant substance. So take the same example of salty water. Okay, throughout the mixture shows the properties of salt and water, whereas in the case of compounds, the new substance has a totally different property. Here we took the example of carbon dioxide. Carbon dioxide doesn't show any properties of both carbon and oxygen. It is a completely different. Now the constituents of mixture can be separated easily by physical methods, whereas the constituents of compounds can be separated only by chemical or electrochemical reactions. Thus, we can summarize the physical and chemical nature of matter in the following order. Matter, it can either be solid, liquid or gas. It is divided into pure substances and mixture. Now, pure substances are of two types, elements and compounds. Elements, they cannot be broken down into simpler substances, say for example copper, oxygen, iron, hydrogen, mercury, etc. Whereas compounds, they have fixed composition, they can be broken down into elements by chemical or electrochemical reactions. Example, water, methane, sugar, salt, etc. Now in the case of mixtures, they have no fixed composition. They are of two types, homogeneous mixtures and heterogeneous mixtures. In homogeneous mixtures, we have a uniform composition, say for example sugar and water, salt and water, sulfur and carbon disulfide, water and alcohol, etc. In the case of heterogeneous mixtures, they have non-uniform composition, for example sand and salt, sugar and salt, water and oil, etc. So that's all for chapter 2, Is Matter Around Us Pure? Tune in soon for the next session. Thank you so much. May God bless you all. Stay safe, take care, and bye-bye.